So just some kind of practical case studies and an idea of some of the savings that you can get in each of these areas, going back to the control side of things. So let's take a stress relieved tempering oven, either commissioned sort of at the OEM or at site. We've seen with some solutions it can take days or even a few weeks to actually dial that furnace into the temperature uniformity that's required. And then we've put an advanced PID controller on that system, and we've actually taken that down to hours rather than days or weeks. So quite a considerable time saving. And if you can imagine, when you're commissioning something, you're taking it through several cycles. So if you can commission it quicker, you're saving all of that energy that you would waste with those extra cycles. So I mentioned a few things about SCR power controllers. One of the developments in SCR power controllers now are that you can network those power controllers. So they can actually learn from what each other are doing. So that could be whether you've got several zones within a furnace or you've got several furnaces. You can have those network power devices talk to each other, and they can actually schedule when they fire, and you can have them really as little energy management units doing load shedding and load sharing. So this is technology that's been available actually for sort of over a decade. And that type of solution, if you take something like a VRT, and even a modern VRT, and do an SCR transformer solution against that VRT, with this networking of devices, you can save sort of in the region of 10% of your energy cost. Similar kind of thing with annealing furnaces. Say you've got a coil that you're annealing, but you can't actually physically get a load thermocouple in the core of the material because of the way the furnace is constructed. So now you can actually start to look at virtual load sensors that actually sense when the entire furnace is up at temperature. So you know the core is at the right temperature. A mix of either looking at the rate of change of the input from the power device and also the PID terms. So you can sort of take those together and you have an algorithm, and then it gives you this virtual sensor. So rather than just relying on sort of historic hour per inch of section to sort of run times, you've got a little bit more detail and data about when that whole furnace is up at temperature. So you've got a bit more confidence about how long to soak it for. And that again, sort of we've seen sort of around about 10% savings typically using that type of solution.